For those who have joined late, so today is the revision session. So this is the revision session. S- I have given you like 8 questions, so you can start doing the questions and tell me the answer. So what is the answer of first one? So what is the, are you done with this question? If yes, please answer me what is the answer of this question. So Aparna, you have joined late. So today, this is the discussion session. Like previously, I have taken some questions. So today, I have make made a presentation and put all the questions that I have taken previously. Main question. So since you have mailed me about like you want to study, you want to know about the previous question that I have done in the class. So this is just a this just previous question that I have done in the class. The others should give me the answer of this question because you were present in the class. And Aparna, if you know this, if you know the solution of this question, you can also solve this question that is there in your screen. The Coulomb energy component in the binding energy of a nucleus is this. The radius of this uniform spherical charge distribution in the nucleus. Okay. And tell me the what is the answer of, like, what is the atomic number value? PDF for this presentation or for previous presentation? Oh, okay, okay. So I'll again send you the video. Okay, huh? So I will do this question. So as you can see in this question, uh, So you can see in this question you are given Coulomb energy component of binding energy. Huh? So you know Coulomb energy component for binding energy value is 3 by 5 E square Z square upon R 1 upon 4 pi epsilon naught, right? This is the value. So you are given the value of this whole term that is written on the right hand side, and that is 18.432. Okay. No, no, no. That is for the different one. When you are reading the other formula, no? I forgot what is the name of that. There is one formula, semi-empirical. Semi-empirical mass formula in that. But here it is like given like Coulomb energy component in the binding energy of the nucleus is this. But the formula for Coulomb energy component in the binding energy is this one: 3 by 5 q square by r, 1 upon 4 pi epsilon naught 3 by 5 q square. So you can no use this one because semi-empirical mass formula is not mentioned. Crane. Crane. In Kenneth's Crane, there is one chapter about it. I guess it's chapter 5 or 4. I'm not sure whether I will confirm it which chapter. Then I'll tell you. Ha 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 ha. Yeah. Who told self energy? Yeah, there is one topic in Crane. So I will like I will go through Crane and I will tell you which topic is that, and I will mail you about it. So put the value which is given in the question, 3 by 5, and you are given if the radius of the spherical charge radius is given, then an e square by 4 pi epsilon naught is given to you 1.44, right? Z square by r is equals to r naught a raised to the power 1 by 3, right? No, there is no need of doing this directly r, because in question z square is 18.432. So z square is 18.432 into 5 upon 1.44 into 3. And what is the value of r? R is given 3 for me, na? 3 will cancel and you will get value 18.432 into 5 upon 1.44. After solving this, you will get 64. You will get some term like 64 point something, but you can round it off to 64. And you will get Z is equals to 8. And what is the element whose atomic number is 8? Oxygen, right? So Z is equals to 8 is the answer. I hope this is clear to everyone. Now, moving on to the next question. Everyone, what about others? I mean, are you guys done with this? You know from where 8 is coming? Because this is a straightforward question. You have to put everything in the formula and get the value of z square, and z will be 8. And this question, do this question, I'll give you a hint. based on Heisenberg uncertainty principle. Try to use both, try to incorporate both the formula, Heisenberg formula, you'll get the answer for this. This formula, and tell me the answer of this question, huh? You can see an electromagnetic pulse has a pulse width of this much, 10 raised to the power minus 3 second. So you know that delta t is given to you. The uncertainty in the momentum of the corresponding photon is given. So uncertainty in the momentum is given, okay, and the uncertainty and the electromagnetic pulse width is given, and you need to find out the value of n. Okay, so you know from the question that you have to use delta E into delta T h cross by 2 formula of Heisenberg uncertainty principle. But here uncertainty in the momentum is given, and you know in photon, what is the formula for E? What is the formula for? Huh. Why? Because the photon rest mass is zero. So the energy formula is E is equals to under root P square C square plus M naught square C4. But in photon case, rest mass is zero. So E is equals to PC. So replace E with PC. So you know delta P is given to you. And C value you know 3 into 10 raised to the power 8. And delta T is also given to you. So from that put all the values, you will get the value of N. And tell me what is. Yes. Okay. Okay, correct. What about others? Other, please also answer, huh? This is a revision of yours because now February is near. January is almost over. Aparna, are you getting? Okay. So the last question you got, like how the answer came? Okay, okay. So this one again I'll do. So this is, huh. Delta E, replace it with C into delta T H cross by 2. Now put the value of delta P. Delta P is 10 raised to the power 9 into 3 into 10 raised to the power 8. Delta T is this, is equals to, okay, you can write is as h upon 4 pi also, no? 6.6 into 10 raised to the power minus 34 upon 4 into 3.14. Solve this. 3 will go there and it is 12. It is 3.14 and it is 10 raised to the power 5. So when you will solve this, it is 6.6. 12 into something. Suppose I'm rounding it off to 3. So 12 into 3, 36. 10 raised to the power minus 39. Yeah, when you will solve this, you will get some value, something 0 point something. If you take this point here, so you will get 10 raised to the power minus 40. So n is equals to 40, right? Okay. Aparna, you got. It depends. Depend 40 or 41. Yeah, because in the answer also the range was given 39 to 41. So any answer is welcome. So this question. Start solving these questions. This is also quite easy question, but there is one trick involved in it. Generally people like because we are always study about half particle, spin half particle. So we know like only two particle will be placed, so most of the people will go and put only two particle in the state. But this is not the case with this one. Try to see that spin 3 by 2 is given. So like how many particle will be present in one state will depend upon the spin. If it is spin half, then only two particle. If it is spin 3 by 2, then four particle. Then try to solve this question because I have given you the hint. 8. 8 what? Minimum excitation energy or what? No, it is, answer is 5. Because see, you will put four particle here, like I'm putting it like that, and four particle will be here, right? So what you will do? So you okay. So when you will excite, so you cannot excite n is equals to 1 to n is equals to 2 because it's not possible, na? Because there are already four particle and you cannot accommodate five particle. But you can excite n is equals to 2 to n is equals to 3. So n square pi square h cross square upon 2 m l square. For n is equals to 3, it is 9 pi square h cross square upon 2 ml square minus, from 2 to 3 we are exciting na. So 4 into pi square h cross square upon 2 ml square. 9 minus 4 is 5 pi square h cross square upon 2 ml square. This is clear to everyone? Aparna, this is clear to you? Okay, yeah, I'll tell you. See, there are 3 by 3 identical quantum particle of spin 3 by 2. Okay, so 3 by 2 spin particle means how many particle you can accommodate in one state is 3 by 2 into 2 plus 1, that is 4. Reason being, because s is same for every particle, spin is same for every particle, but the thing that will change is ms. So ms will be different for every particle, and ms will vary from, how ms will vary from, it will vary from minus s to s. And how you will find ms? Ms is equals to 2s plus 1 is equals to, sorry, ms varies from minus s to s, na? So minus s will be minus 3 by 2 to 3 by 2, and in between minus 3 by 2 to 3 by 2, minus 1 by 2 and 1 by 2 will also come. Hmm? So that means there are four particles, four particle with s and ms value. 3 by 2 minus 3 by 2, there is one particle. 3 by 2 minus 1 by 2, there is second particle. And 3 by 2, 1 by 2, third particle. And 3 by 2, okay. So these four particle will accommodate one state, and the same these four particle will go to n is equals to 2 state, because there are 8 na, 8. So 4 will come here, 4 will come here. Okay, now you have to excite this. You cannot excite n is equals to 1 to n is equals to 2 because there are already maximum 4. So you can excite n is equals to 2 to n is equals to 3, you will get 5. If you want to excite n is equals to 1 to n is equals to 3, you will get answer 8. But in between 5 and 8, which one is smaller? 5 na. So 5 is the minimum, right? Mm-hmm. Hmm. Because हाँ Hmm. Okay, okay. So you have done it in a different way. So take the picture of this question and try to post it in the group, in the chat box, so that we can also see. Now this question. This is very easy question. It's from nuclear physics. All you need to do is to find Q value. And Q value, is mass of reactant minus mass of product. And there is one more formula for Q value. Other formula is kinetic energy of product. Try to because in question it is given mass is given, so try to apply this formula. You will get the answer. And one more thing, it is given in AMU. So no need to multiply it with 931 and find out in MEV. It is given in AMU. So you just directly put these values and find out the answer. Yes, Aparna. Yes. uh, so you joined the Telegram group, right? What is the answer? Okay, one. First, Aparna, you just tell me what you want to say. Hello. Okay, yeah, I'm not in that Telegram group. Yeah. Okay. 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 Thank you. Thank you. So the answer, yes, 0.84. How 0.84? Then it's not 0.84. Wait, I'll do. So mass of reactant. This is 151.921749 plus neutron mass is 1.008665 minus 151.919756 minus 1.007825. Let me do some calculation, huh? Wait. 151.921749 plus 1.008665 is equals to 152 152.930414 minus 151.919756 plus 1.007825 gives you 159 152.927581. So it will be, yeah, I think your answer is correct because it is 10 raised to the power minus 3 na, minus 152.927581. Yes, it is 0.00283. So it will be 2.83 into 10 raised to the power minus 3. So 10 raised to the power minus 3 is given here, na? So you have to do in terms of 10 raised to the power minus 3. So the answer is 2.830. Got it, everyone? Moving on to the next question. So this question again, this is quite easy question, and this came for 2 marks. This question. So the value of magnetic field required to maintain a non-relativistic proton of energy 1 MeV in a circular orbit of radius this. So you know when it is in a circular orbit, so centripetal force required to maintain the necessary motion will be provided by the magnetic field. So both the forces will be equal to each other. And you know centripetal force is mv square by r, and when the particle is in motion, like in circular motion, so you know magnetic field is equals to qvb, right? So the qvb, now I have given you this formula, and from this formula you can find out the magnetic field, this magnetic field, and it's very easy. So we will cancel v, b is equals to mv by qr. M is M, you know, like 1.67 given in the question, 10 raised to the power minus 27. V is V is not given to us. Okay, V is not given to us. Q is 1.6 into 10 raised to the power minus 19, and R is given to us 100 mm. So we can convert it into meter, 10 raised to the power minus 3, right? So V is not given to us. So how you will find V? E is given to us 1 MeV. So you know E is equals to, what is the formula for E? Ha, ha. So uh, you can do P, MV is half MV square, right? So V is equals to 2 E by M. Okay? 2 E by M. Sorry, under root 2 E by M. Put V value in here. 1.67 into 10 raised to power minus 27 upon these term. Then under root 2 E by M. Now you can do 1.67 into 10 raised to the power minus 27 upon 1.6 into 10 raised to the power minus 19, 100 into 10 raised to the power minus 3 into under root 2 E is 1, it is given in 1 MeV, but I want in joule. I want in SI unit. So 1 EV is equals to 1.6 into 10 raised to the power minus 19. So 1 MeV is equals to 1.6 into 10 raised to the power minus 13, right? 1.6 into 10 raised to the power minus 13 upon m is 1.67 into 10 raised to the power minus 27. Now you can round it off to 1.6. I'm doing it like this way just to show you. So it is uh, it will go above. It is minus 1, minus 20, so it is minus 7. Here also I am doing the same way. 2 into this will go above, this is 14. So it is 10 raised to the power 7. This will come out from square root as 10 raised to the power 7 into root 2. So it is 1.44. I hope so everyone got this, how this is coming, right? Now next question. Do this question. Again I will give you the hint for this. So it is first forbidden beta decay. First forbidden. So here you can see it is first forbidden beta decay. So for first forbidden beta decay, L is equals to 1, and the change in overall momentum is, change in overall angular momentum is 0 plus minus 1. Yes, 0 plus minus 1 and I guess plus minus 2. These three values. Because S is either 0 or S is equals to 1. Yeah. So I have given you the hint. Please do this question. This is very easy question. I hope the question is clear to everyone because which one? C. See, L is equals to 1. So L is equals to 1, that means there will be a change in parity. Parity is minus 1 raised to the power L. So if L is 1, so parity will change. So we can, like, we can ignore these two B and D. These two options are wrong because parity is not changing in it. Now 7 by 2 and 1 by 2. So delta I will be 7 by 2 minus 1 by 2. So it will be 6 by 2 is equals to 3. But I told you like change in the angular momentum should have value 0, plus minus 1 or plus minus 2. Only these three value it can take. But with 1 by 2 it is taking plus minus 3. So that means it is not correct. If you see for C, 7 by 2 minus 3 by 2 is 4 by 2. 4 by 2 divided by 2 is equals to 2. And parity is changing. That means the answer is C. Clear to everyone? Now moving on to the, yes, yes. Okay. Second forbidden. Second forbidden, see, first is allowed beta decay. So for allowed beta decay, we have L is equals to 0. And there are two conditions now. Either spin will be anti-parallel, because in beta decay we have two particles. No? There is one nuclei. It is changing to other nuclei Y. Huh? And then there is electron, and then there is antineutrino. Both are spin half particles. So two particles are involved with the spin half. Okay. Now, for allowed beta decay, we have L is equals to 0. And now there are two cases when both the particles that are emitted during decay are anti-parallel. When they are anti-parallel, that means spin is equals to 0. And when they are parallel, then spin is equals to 1. So this case falls into Fermi decay, and this one S is equals to 1 is Gamow-Taylor decay. Okay. Now, how delta I will change? Delta I means total angular momentum. So you know delta I varies from minus L minus S to L plus S. Take first condition when L is equals to 0 and S is equals to 0. So in this case it is 0 only, na, because 0 0 both are 0. But take other case when delta I is equals to L is equals to 0 and S is 1. So again the same thing, it will give you 1 1, right? So the delta I can take value 0 and plus minus 1. And there is a parity. How will you define parity? Minus 1 raised to the power L, right? Minus 1 raised to the power L. And L is 0. So that means minus 1 raised to the power 0 is 1. That means he is not changing. Now for the second forbidden beta decay. L is equals to 2 and S is either 0 or 1. Take this case when S is 0. When S is 0, we have 2 minus 0, 2, 2 plus 0. So one value is 2 that is coming. And now take other case when S is equals to 1, right? When S is equals to 1, you have L 2, L is equals to 2, right? Minus 1 to 2 plus 1. So you have 1, 2, 3. That means 1, 2, 3. So these are the values. These are the values. And now for fourth beta decay, then again you have L is equals to 3 and you will do the same way. So it will have 1, 2, 3, 4. It will go for those values. Clear? See, from beta decay, one question will definitely come. Either it will come in the form of match the following. You will be given some decay that are going on. You will be asked find out the probability that this decay will be going from which process, either first forbidden, second forbidden, third forbidden, or allowed. So from beta. Hmm. See, from beta decay, every year they are asking one question, and for 1 mark, sometime it is for 1 marks, or sometime it is of 2 marks. So you should know the concept of it, huh? Now this question, this is also very easy question. So I have done this question so many times in the class. And these questions are also coming in the exam for 1 marks. If you see the pattern of gate. B, yes. So this is oxygen 8, 17, and these two are isotopes of oxygen. Now if you see, proton is even in both the case. When you have even number of protons, then surely the total angular momentum due to these proton will be zero, because they will couple up to give total angular momentum zero. Whenever there is odd, you have to go for it. Now find out n. N will be 15 minus 8 is 7. For this case, n is 7. And for this case, it is 9. So start filling up. Shell model, then 1s 1 by 2, 1p 3 by 2, 1p 1 by 2. This will accommodate how many proton? Sorry, neutron? 2 into 1 by 2 plus 1. And how do you know how many proton this will, sorry, neutron this will accommodate? The subscript that is given here. These subscript. Okay. That means it will accommodate 2 neutron. And 3 by 2 will accommodate how many? 2 into 3 by 2 plus 1 is equals to 4. Okay. So it will accommodate 2, it will 4, and it will 1. 4, 6, 7. That means it is last neutron is falling in this state, 1p 1 by 2. So that means the total angular momentum, this is total angular momentum. This is given in subscript, subscript, this is total angular momentum. So 1 by 2. And this is p. So S, P, D, F. For P, for S, L is 0. For P, it is 1. For D, it is 2. For F, it is 3. So parity will be minus 1 raised to the power L. And now we have P state. So for P, L is 1. So minus 1 raised to the power 1 is 1. So it is minus, right? Now for the next case, when neutron is 9. So similar, same way, 1 s 1 by 2, 1p 3 by 2, 1p 1 by 2, 1d 5 by 2. Here it will accommodate 2 neutron, this will 4, this will 2, 4, 6, 7, 8. The last one go for this one. So the total angular momentum is 5 by 2. 5 by 2, and parity will be minus 1 raised to the power L. And you know, for D, L is equals to 2, right? So the parity is positive. So that means positive. So the answer is this, B. This is very easy question, and these questions are also coming, frequently coming in GATE. Oxygen 16, like this, 8AO16. Okay. So for this one, you can see N is 0, sorry, N is 8, P is 8. So both will give 0, right? 0. Both will give 0. So the total angular momentum will be 0. Now, how you will define parity? So for parity, start filling this. This is 8, na? So 8. This will accommodate 2, this will 4, and this will 2. So minus 1 raised to the power L. It is P. So 1. So 0 minus. Got it? Hmm. Then proton, you will fill proton in this way, like the way I have done for neutron. Any one of them. जो odd है, the one which is odd, the one which, that will decide your parity and angular momentum. Keep that thing in mind, the one which is odd. Okay, 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 okay. So this is where is my? I have given you. Okay, so you were not in my first class, so for that I have given you the chart. So this goes like this: 1s 1 by 2, 1p 3 by 2, 1p 1 by 2, 1d 5 by 2, 2s 2s 1 by 2, 1d 3 by 2, then 1f 7 by 2, 2p 3 by 2, and 1f 5 by 2. It will go along by 1, 2, 3, 4, 5, 6, 7, 8, 9. This much is enough for exam, because they won't ask for atoms, element having atomic number more than 30, or they will ask only these element which have atomic number less than 30. So this much is enough. Hmm. Yes, if both the proton and neutron number are odd. So for both, if both are odd, suppose, then you have to find out N and P are odd, na? Both odd. So what you need to do? Just find out J value. Suppose N is odd, and I have given J1 and L1. I have assigned like total angular momentum and orbital angular momentum J1 L1 to L1 to P, sorry, N, and for P I have assigned J2 and L2. So try to find out these two values. Okay, try to find out these two values. Then what you have to do? J1 plus J2 plus L1 plus L2. Add these four, and if it is coming even, if it is coming even, then spin will be J1 minus J2. And if it is coming odd, then spin will be J1 plus J2, right? And parity will be, how you will define parity? Parity is a multiplicative quantity, na? Yes. No, no, multiplicative. Minus 1 into L minus 1. Ha, ha, ha. Yeah. So minus 1 raised to the power L1 plus L2. Okay. So you need to, yes, I will provide you PDF of that first lecture. Okay, after this class, I will provide you the PDF of that first lecture. Okay. I will provide you. I'll provide you. Now, this question, positronium. So in the question, positronium is given, huh? Is an atom made up of electron plus positron. Positron is E positive, right? And you need to find out the Bohr radius for the ground state of the hydrogen atom is given. Ground state of hydrogen atom is given. Now you need to find it out for positronium. So for that you should know the ground state value for hydrogen atom, huh? So here you can see the value for it is 4 pi epsilon naught h cross square upon z m e square. This is the case for hydrogen, because in hydrogen you know very well that there is electron and there is proton. So their combined mass will be 1 upon mu me plus mp. So 1 upon mu is equals to me plus mp. Okay. So mu is equals to me mp upon me plus mp. You know the mass of proton is very much larger than electron. So we can write me mp upon mp, and this will cancel. So in case of hydrogen, mu is replaced by me. But there is a trick in the question, because in question it is positronium. So for positronium, electron and positron are there. Both have same mass. So 1 upon mu will be me square upon me plus me. Sorry, mu is equals to. So this will like me by 2, right? So when you will put the value of mu here, so it will become 4 pi epsilon naught h cross upon z me by 2. 2 will go above, and this is like this, and this is ground state for hydrogen atom, which is given to you 0.53. 2 into will give you the value. Clear? Clear? Because it's a very straightforward question, but there is one thing involved in it, because it is positronium, not hydrogen. For hydrogen, there is proton. That's why we have mass of electron in the formula. But for other cases, you have to find out the reduced mass. 1 upon mu is equals to all both the atoms, both the elements component like electron, positron involved in the question, which is given to you. I hope this today class is clear to everyone. So as you have told me like you want the pdf of previous classes also, so I will provide you and try to give it to other people also during through telegram, huh? I hope. Now, telegram group, Harish, so add the Sayantan to the telegram group. Hmm. Okay, send him the link of telegram group. Others are there in the telegram group, like, right?